The industries we serve create products assembled from a wide variety of parts. Each part has characteristics that affect the way in which it should be manufactured. Aerospace parts, for example, are not only complex in shape, but must be made to precise tolerances and to a high quality, factors that are critical to performance and safety. The parts for machinery and equipment may be simpler in shape but still complex in detail and can be demanding in terms of precision. The vehicles we drive are of course complex assemblies of many types of components, manufactured using a wide range of processes such as high-volume machining, metal casting, and plastic molding to sheet metal stamping. And in this last example, a vast array of products are assembled from parts that are made in high volume using tooling, such as every molded plastic component. Almost every metal clip and bracket is stamped using some form of die tooling. The process to manufacture this type of part requires the extra steps needed to design and manufacture the mold or die tooling in order to deliver the required component. In this example, we will see one half of some mold tooling, manufactured to mold the case for a thermal imaging camera. The tool shape will be machined precisely from hard steels. Then this tooling is used within a plastic injection molding machine to produce the casting. Manufacturing parts like these we have shown is the first stage in creating real products from virtual designs. Whatever the complete product, there can be hundreds, perhaps thousands of individual parts involved. Each must be manufactured to meet specific delivery, cost, and performance criteria. Producing a product that will meet these requirements and be successful in its market requires optimizing the use of manufacturing capability to deliver production efficiency in part manufacturing. For OEMs or for suppliers, this is a critical contributor to overall business value. In this presentation, we will consider how PLM software can contribute to greater business value in part manufacturing. In this sample chart, we illustrate some of the ways that efficient part manufacturing can contribute to business value. The chart is based on an IT value map as drawn by Dr. Greaves in his book on product lifecycle management. Here, value is shown as a measure of income relative to assets employed. In this case, the assets could be equipment, such as machine tools or tooling equipment. We want to maximize the use of that equipment for maximum value. Income will be affected positively by greater sales of a product that is made up of parts manufactured on time and to the right specification. Income will also be increased when costs are reduced, for example, by less waste or increased productivity. Each of the above can be impacted by the way in which a company prepares for and executes part manufacturing. We naturally associate most of these activities that contribute to part manufacturing efficiency with the production phase of the product lifecycle. But what happens on the shop floor is driven by manufacturing engineering. As with most activities, the success and execution is highly dependent on the thoroughness of the plan. In this case, the part manufacturing plan. In manufacturing engineering, we create the plan that determines how, with what resources, and where a part should be manufactured. A part manufacturing plan that's complete and accurate and delivered when needed in production will have a direct impact on each of these initiatives. Many part manufacturers will be able to identify with at least some of these more detailed example issues, such as unused machining time or wasted materials due to machining errors or using the wrong data. In each case, we could link these issues to some aspect of the manufacturing plan and how it is developed and validated. On this chart, we show some example benefits achieved as a result of perfecting the manufacturing plan and improving the way the plan is created, with positive results in production. For example, reductions in NC programming time, achieved perhaps through the use of automated CAM software or faster access to programming data, can translate into reduced shop floor errors as the NC programmer may have more time for validation and checking before the machining data is added to the manufacturing plan. Analysts and consultants, such as Dr. Greaves, whose value diagram we showed a few moments ago, confirm the importance of the manufacturing plan for success on the shop floor. In the following sections of this presentation on part manufacturing, we will look at some of the key challenges involved in defining the manufacturing plan in a process involving many different functions and the importance of a single source of data and process knowledge. Then at how we should optimize each manufacturing process, such as machining, within the plan. And finally, in the third section, at how we can connect the plan to production.